We all know about the cosmic monster that eats everything, even light. But what if it had a twin? A perfect shining opposite? That's what we're diving into today, a cosmic tale of two singularities.
I mean, really think about that. In physics, right, there's always a counterforce. For every action, there's that equal and opposite reaction. So it kind of makes you wonder, doesn't it? Does the universe's ultimate vacuum cleaner have, like, a cosmic leaf blower just spitting everything back out? Let's dig in.
All right, so first things first. Before we can even get into the wild hypothetical stuff, we've got to have a solid foundation in what's real, what we've actually seen. So let's start with the undisputed champ of gravity, the cosmic devourer itself, the black hole.
And just to be super clear, we're not talking about just strong gravity. No, this is gravity turned up to 11, an absolutely impossible extreme. I mean, imagine gravity so intense that it doesn't just pull on stuff, it actually breaks space and time, literally tearing a hole in the very fabric of the universe.
So how in the world does something this crazy even get made? Well, it all starts with a really, really spectacular death. You take a massive star, way bigger than our sun, and it runs out of fuel. Without that nuclear fire pushing outwards, gravity just wins. It collapses in on itself in a massive supernova explosion, one of the most violent events in the cosmos. And the core that's left over? It just keeps crushing and crushing until it becomes a single point of infinite density, an object with basically zero size but incredible mass. That's what scientists call a singularity.
Okay, but here's where it gets really wild. That singularity creates this invisible boundary around it. It's called the event horizon. The best way to think about it is like the edge of a waterfall in space, a point of no return. Before you cross that line, you could, in theory, fire up your engines and get away. But the second you cross it, that's it. You're going over. There is absolutely no escape. It's the literal point of no return.
Okay, so we've met the devourer. We get it. Now, let's take a big step. We're going to move away from the stuff we've proven and journey into the purely theoretical. We're shifting from what we know is out there to what the math tells us could be out there. It's time to meet the black hole's mirror image, its cosmic opposite, the white hole. So, I want you to take everything we just talked about with black holes and just flip it completely on its head. Instead of being a cosmic drain sucking everything in, a white hole is, in theory, a cosmic fountain. It's a place that is constantly and probably violently spewing out matter and energy. But here's the kicker. You can't get into it from the outside. Now here is the absolute most important thing to remember. While white holes look beautiful on paper, in Einstein's equations, the number of them we've actually seen out there in the real universe, it's a big fat zero, nada. They're a fascinating idea, but most physicists are pretty skeptical. And that's because they seem to break a major rule of the universe, the second law of thermodynamics. Basically, that law says that things always get more chaotic, more disordered. A white hole just spontaneously creating order by spitting things out, that would be like watching a shattered glass jump off the floor and put itself back together. It just doesn't happen.
And yeah, just like its dark twin, a white hole would have an event horizon too. But this one's completely backwards. Instead of a point of no return, it's a point of no entry. Imagine trying to fly your ship towards it. The closer you get, the harder it pushes you away. It's like a cosmic force field. You can look, but you absolutely cannot touch. All right, so we've got our two contenders. In one corner, the unstoppable force of attraction, the black hole, and in the other, the theoretical unstoppable force of repulsion, the white hole. It's time to put them side by side, the ultimate cosmic showdown.
At the core of both of these things is that crazy idea, the singularity. But they represent two totally different sides of what infinity could mean for our universe. So let's get right into the details.
And this chart just lays it all out perfectly. Look at their behavior. A black hole pulls things in, a white hole spits them out. Simple as that. The event horizon, a black hole is a one-way door in, a white hole is a one-way door out. What about visibility? Well, a black hole is black. We only see it because of the mess it makes around it. A white hole, though, it would be crazy bright, a constant explosion of light and energy, and then the big one, scientific status. Black holes, they're real. We've taken pictures. They are confirmed. White holes, still just an idea, purely hypothetical. So let's just boil this all down to one simple rule for each. For a black hole, the rule is absolute. Nothing gets out, period. It is a one-way trip. And for the white hole, the rule is just as simple, just the opposite.
Nothing can get in. Ever. A perfect cosmic mirror image.
Okay, so at this point you might be thinking, this is a really cool science fiction idea. But if white holes aren't real, why are we even talking about them? Why do scientists waste their time on this? It's a fair question. Why does this stuff matter?
Well, the reason is, these kinds of cosmic mysteries are what push our understanding of physics to the absolute limit. Sometimes by asking questions about things that might not even exist, we learn more about the things that do. Thinking about white holes helps us poke at the biggest questions there are. How did the universe even begin? What's going to happen to it in the end? It forces us to really think about the fundamental nature of space and time. And honestly, it's also just about our deep, basic human need to understand the incredible cosmos we live in.
And all of this leaves us with one last mind-bending question. Are they really two different things? Or could they be connected? Are they maybe two sides of the same cosmic coin? I mean, some theories even suggest that everything that falls into a black hole might get shot out of a white hole somewhere else, maybe even in a different universe, like a cosmic wormhole. We have no idea if that's true, but asking the question, that's always the first step toward the next big discovery.